All right, bits are flowing. YouTube is green. And we'll do an audio check real quick. And we'll do an audio check real quick. All right, I noticed it was a little bit quiet when I backed away on yesterday's stream. Let me just open up the camera here. I'm in a hurry because my rice will be done. Well, I might have to add like 5 minutes, but in 15 minutes. So I'll probably just run upstairs and then back down without ending the stream, because I think it'll be longer than 15 minutes, infamously. Whoops. All right, so let the people roll in, all 0 of them that ever join. So yeah, yesterday was a pretty cool one. Talked about messaging interfaces, unifying email and DMs at the code level. So this Nostr thing, I just learned about it. Looks pretty interesting. I went through about half of the, whatever they are, NIPs. I don't know what it stands for yet, but it's all public domain. It's pretty cool. It addresses shortcomings of Mastodon, which is cool. And it actually uses 3 techniques that I already was aware of and thinking about, which is pretty awesome. And, I mean, given what I'm building, you can see how what I'm doing definitely translates in. So first we'll look at the code that I did today, and then we'll get into that. So code related to Hogumathi, the Twitter and Mastodon client. By the way, if you're on Patreon, I made my first post on there in a long time. So there's some GIFs for you, and there's some code that is not going to be released for like a week or 2. So I was talking about getting into a cadence of release cycles. So basically what we're seeing now will be the next thing released on Patreon. What I released on Patreon today will be the next thing to go on Glitch. And then I have a release for Glitch ready to deploy, but I didn't have my Glitch password with me today. So yeah, so get on Patreon, and we're trying to get to $1,500 a month. So, I mean, $5 a month, like seriously, you can't afford $5 a month? Or $150 at $10 a month? Come on, you can't afford $10 a month? $9 a month? You know, thank you if you're already on there. All right, so continuing where we left off with Hogumathi update 4, started looking at strong types and got into it again today. And so I ended up just basically from memory and from a little bit of looking at the code, modeled Twitter's search API response. So since things are dependent top to bottom, the very bottom is going to be tweet search response. So it's got data, meta, includes. So data is a list of tweet, metadata is tweet search metadata, includes are the tweet expansions. So, I mean, obviously you can read, I don't need to read out every single thing. If you know the API, it should look pretty familiar. So I could actually release this as a standalone library as well for Twitter. I just did a quick check and it didn't seem like anybody's done it, but not extensive by far. And since I'm just learning Python still, it doesn't bother me to implement things that people have done before because I'm doing it for my own learning. So tweet search response, and I'll just show you real quick where we use that. So we use it both in get timeline and search tweets. And then search tweets is used by a couple other things, and get timelines is used by a couple other things. So if a field is not present here, it'll just omit it. So then tweet search meta, that has count. And I'm pretty sure I remember seeing this. I've got to double check into it, but I saw a result count today. Next token, newest ID, oldest ID. I think there might be a prev token, but I never use it, and so I didn't add it. So then tweet expansions. If you've requested anything in the tweet expansions part of the query, those will go here. So you might expand users, media, and tweets. So we talked about Twitter versus Mastodon query API a few videos back if you're on the Hogumathi playlist. And how on Mastodon a activity has like everything nested inside it. So every activity has the account that created it nested inside it, as opposed to saying expand the author ID and then put it into this collection of users. And then user, what I use in my code is ID, username, created at, name, verified. There's more in the API, so I can go and finish it out. But, you know, so you see that I'm using some fields are required and many are optional. So like all the optional ones will be user.fields in the API doc. And like, you know, if you're a tooling person, you might be thinking, this could just be generated from Twitter's API doc or whatever. And yes, you're exactly right. But sometimes it's prudent to just write it by hand. I mean, this took me all of like maybe 45 minutes sitting at the library, so no big deal. So yeah, then the tweet itself has ID, created at, text, and then the rest are optional. We talked yesterday about conversation ID and reply ID. Then we've got author ID that expands to a user. Reference tweets, that's a special case. So it's a tweet ID and a type. So it might be replied to, quoted, or retweeted. And I did look at enum today. I found Python does have enum. I don't have a certain answer as to whether it works with the data classes, which is a built-in feature of Python. It should, and I found a nuance of data classes as well, which is if you extend, so video media extends media and photo media extends it. So when it's building these, it goes from the most specific to the most general. So the, you know, if it's a tree of classes, it goes from the leaves up to the parents, up to the parents, up to the parents, and it adds them in reverse order. And so if you have any optionals, they have to only be in either the leaf, the end of the leaf, because the order matters here as far as what the optional ones are. Because you can't have optional ones before non-optional ones. And so if you combine two classes together, then the optional ones always have to end up at the end. And so if you have any optionals in media, everything that extends from it has to be optional. Hopefully that makes sense. So we've got media, we've got photo media and video media. And we've got, say, media key and type, I think. Yeah. And then on photo we have just say URL, and on video we have preview image URL, so PI URL. So if we have anything optional, say this becomes optional, then since we go from bottom to top, all of these, this is okay to do, it just means that all of these have to become optional equals none, optional equals none. So, I mean, it's a trade-off you can make for your hierarchy. It gets sticky because there is mix-in inheritance in Python too. So you could have some, multimedia media that, to reunify them. But as a result, since one of these have an optional field, all of these also have to be optional. So anyway, hair-splitting detail if you're not a programmer. Pardon me. We'll just leave it in case we need more room. Okay. So yeah, basically I just went through, created the whole hierarchy, and I did just do some aliasing. So URL is string, tweet ID, user ID, date, media key, string. I think we can use a date time for this, so all good. All right, so let's go back to the code itself. And I did something because, I've been printing out the parsed results to stuff, but here I actually just I came with the method to go full circle that I documented, and if I ever start doing written content. So basically, first create data representation of the response JSON payload. Second, use a round trip with decite.fromDict and dataclasses.asDict. So we get the response, we load it to JSON, we go typed response equals fromDict with the response JSON as data and tweet search response as the data class. And then checked response, we actually go again asDict type response. And this will not quite yield the exact input because asDict will include all of the null fields as well. And so we've got this function called cleanDict. And that just leaves, it takes out empty keys. So don't worry if you don't quite know what this code does. The point of this function is if there's a null field anywhere in a nested dictionary, so if there's a dictionary inside the dictionary, it goes down there as well, then it just replaces that key, removes that key. And that's just a little bit of a workaround. Response. And that is a stage in our process as well. So tweet get timeline. All right, so just showing you what it does. So typed response equals fromDict with this typed class. So now we've got checked response equals the dictionary, back to a dictionary from our typed, and then take out the nulls. So it should look basically like the minimal set of everything that we put up into the model. Part of my scrolling around, I know it can be jarring. All right, so the checked response is again a map. Now what do we do? So because dictionaries and objects have different syntax, if we have the object, then we access things with t.id. But if we have t as a dict, which is what we're doing now, then we actually don't have the dot. So it's not like JavaScript where you can do it either way. So all of our code right now is written like this. And as far as taking out the nulls, why do we have to do that? Because there are cases where we're looking for the thing. Uh-oh, there's the rice. I'll be back. Don't forget to get on my Patreon. If you're already signed up to Patreon and have your card in there, you can do it by the time I have my rice figured out. I'll just be like 1 or 2 minutes. Okay, we have 8 minutes more on the rice. I adjusted the ratio of water. I'm starting to cook only 1 cup instead of 2, just so I make it more frequently, but it's fresher, more fresh. So in JavaScript, you can access an object either way, but in Python data classes, it ends up turning into an object, which is different than a dict. So really, a tweet is an object, and that's where the difference is. So the reason we strip out the empty keys first is because, like in templates, for example, something might be just checking for an object that exists, but if it's null, then the key is there. It's like if something is using if this object is in this, then you know, it's in it, but we'd have to add an extra check to make sure that it's not none, which is fine. Maybe we should have done that to begin with, but like, you know, being a newbie, whatever, we don't end up doing that. So by using the clean dict, we take out the key, so anything that's using a thing in key will succeed. And so part of our project, so 1, create the data class representation, 2, round trip with the from dict and as dict, and use clean dict to remove empty keys, fix until no errors. So fix until there's no errors, that would just be like values missing from the model up above, and you fix the errors by adding the value to the model. And let's see, just that decite thing, I did mention it the other day. Let me just pull up that documentation. So it's just a reverser for data class. So you've got this data class, it turns into this JSON, and then from dict, it'll turn it back into that, and then you can assert that they're the same. Data classes are non-mutable as well, so that's something I'm just finding out, so that has to be okay for your use case. There is a way to there's a data classes replace method, and so it's basically the same as an immutable update if you're familiar with Clojure. All right, so then the next thing would be so basically we want to get the code working as is, and then we actually do go ahead and remove clean dict, because once we convert it to the dot syntax, we're going to have all the same logic errors anyway. And so we might as well just fix one thing at a time. So now we fix it with the dict syntax still by leaving the nulls in. So it's basically going to be those in checks. And I'll just basically write in my notes key in object errors. So next we remove clean dict, and basically now the thing we're fixing is those logic errors by handling the none case, because the data class always has all the fields, meaning those same checks will need to be done for a data class anyway. So we go ahead and add those checks against the dictionary syntax. Once that works, then we add a parameter to the methods, and since in Python you can do them named and with optional values. So basically what that would be to add a method to getTimeline called just return data class and set it to false to begin with. So leave it as is, nothing changes, everything stays the same, right? And then at the end, if return data classes, else this. Right? Makes sense? So basically anywhere now we set, then we look for references to getTimeline. So there's one here, and here it's just a thin layer, and so we'd want to do the same thing here, return data classes equals false, and then pass that through. And then anywhere get home timeline exists, we basically, that's what's going to be consuming the code. And so we'll just do a search through the project for this function. We'll find every instance. We'll set it to return data class equals true, and then we'll update it to use the dot syntax. And there's probably low-hanging fruit. It's like the edge functions that don't pass the data into anything else first, and then you can get closer and closer to the core that's passing the objects around. And eventually, all of your uses of the dict syntax will be gone. And I didn't even type this one in my notes. But then, I mean, this is an obvious step. You can probably think, you know, remove return data classes parameter from methods as they are when all references use data classes. Right? Makes sense. So when everything is passing use data classes equal true, all the syntax is updated, boom, you're good. And this will apply anywhere that you're using some typed thing. Like there's things other than data classes, which was added in Python 3. There's solutions added in Python 2 as well. But I'm just not going to be interested in Python 2, I think, unless, you know, some project calls for it. Yeah. So that's typed objects. Now typed methods, formal interfaces, if you will. So in Clojure, we've got something called protocols, and I figured out that in Python, we've got something called protocols as well. So for example, back to that same file, tweet source. So API v2 tweet source and archive tweet source. So they've got some functions, but the signatures vary. So the goal, I found out early on that just doing inheritance in Python, these did both extend a tweet source general class, but it didn't seem, well, it just felt like over-engineering, and my focus, like at first I used classes as little as possible. So I'm just kind of like adding thing, adding thing, adding thing. And so, but I noticed that the implementations were not the same in the subclasses as in the parent class, and it didn't give me any type warnings or anything. There's my rice again. And while you think about this, think about giving me $5 or $10 a month. I'll be back in 1 minute. All right. This is actually breakfast for me. So, yeah, the rice needs a couple more minutes. I think I just added too much water. But texture is good, and the beans still a little al dente. So, let's see, where were we? Right, so protocols will actually give you some type checking built in. And in this typing package, like, oh, I didn't point out explicitly, but that's where those types were coming from in the code that we were looking at, list, etc. So optional list. There's dict somewhere. I don't know if I use it or not. Oh, that's a strategy too that we can use in porting, is if you're not sure of something, then make it a dict. Like, if you haven't typed out the mention entity yet, make mentions an optional list of dict, for example. Let's see. Use dict for yet to be defined data classes in step 1. So create a data class representation of the response JSON payload. I could just say JSON or dict payload for yet to be determined. So then you just get back this and you look, I print them out so I see what's coming out, and then I just add whatever keys are there to the data class definition. And, you know, we can polish it off by looking at the API doc, but all this can be done without the API doc. So from typing, import list dict optional protocol. So there were a couple examples in here, and I haven't used these arrows for return type yet either. But yeah, so these PEP documents are pretty helpful. Recursive protocols, that's pretty advanced. Merging and extending protocols, so I mentioned there's mix-in typing. So pcolor with the protocol. So there's a class-based inheritance, and there's also like it works like duck typing basically as well. So this is new to me. I'm definitely like, I got into Java because I started using PHP like Java, and so this concrete, it implements it. Error in type checker. Oh yeah. So basically this is just saying that the template methods, the protocol methods can't use fields that they don't define, and I think Clojure may be similar. It's been years since I've used Clojure, unfortunately. I love it, but Python works, it's practical. Babashka guys, if there's Babashka in Windows Store, I would definitely be using that. There's not Java in Windows Store, but Babashka is native. So if we could get on that. There's also Lua and Python, so that's what Windows S mode people have. So supports close is a protocol. Close with no arguments and returns none. So resource close, no arguments, returns none. And then we want to say close int has no close method. So this is because the type checker takes iterable of supports close. For t and thing, t.close, there's an error. Int has no method, no close method. So that you would get without the type checking. Abstract method. I'm not being clear at all on this. Like, I'm literally just learning this, and I have not done a demo with this yet. So this is, this is the next step after data classes. So you get your types to be strongly typed, and then you get your methods to be protocols, strongly typed input and output. So you can almost picture it as like the types are the leaves, and then, those go into any old method. You keep it as close to working as possible, and then you add typing. And so you can add typing to the types first before the methods, because then you have the types defined to decorate the method signatures with, right? So typically Python program, especially for a newbie, you just will have undecorated methods. So then you need to decorate it with something first. So your data structure, your data, your objects, your object graph, your model, however you want to call it, will be the things that you actually decorate the functions with. So my rice should be done. I give it time to cool off too, so I'll be back in a minute or less. All right, rice is done. The beans need just like a teeny tiny bit more. So they were on the lowest setting on the biggest burner, so I put them on a low setting on the smallest burner. And I didn't turn a timer on, so hopefully we don't mess them up, but should be good. Beans are good for simmering. So yeah, I'll definitely have to go through and mess with protocols tomorrow. And so now this is probably the part that everyone's waiting for, this Nostr thing. Just got a 14 Bitcoin donation. All of it's public domain. So I'm surprised, like, I don't know if I just haven't seen it or what the deal is, but it just came onto my radar. And so, yeah, basically my feedback on it. So it's mostly protocol. So I like this aspect of XMPP with the XEPs. So basic protocol. So this uses like so many elements of stuff that I've already been thinking about. So it uses SHA-256 of the serialized content, which is an event. It uses a pub key as an identifier. There is a open timestamp attestation, and yeah, so basically this is, so the three aspects of this that are really good that I've talked about already are, and actually incorporated into my own software, is using SHA-256 some. It's called content addressable hashing. And I'm by no means a pioneer of this. It's just like, I'm just reading this like, man, I was literally like one step away from this. Like, this is literally what I've been imagining. I had tunnel vision though for doing it on Tor, which this will work on Tor as well. But like for me, a limiting factor was that Tor does not exist on Windows S mode, and I've looked for Python, pure Python implementations of Tor, but it doesn't seem to work. So that's another aspect in the content addressable hashing. But so content addressable hashing. And this project I don't think uses this by name. It's also known as CAH. It's like a common thing. Again, I'm not groundbreaking anything here. But basically, if you've got a string that says hi, then your ID could be SHA-256, which is deterministic of S. And so basically the content of your file is the name of the file. So then you could open content / and F for format if you're a Pythoner, ID, don't need an extension, W, right? So basically you get the hash of the content and then you write it to content / ID. And then when something requests then we do open content / ID again. And this is just pseudocode at this point. Read of, content / ID. So then it'll return hi. And so if you know the content that you want, then you can get the hash of it and then save it. Like it doesn't seem that useful unless you have a specific use case. Like in this case, you know, hi is extremely contrived. So in this case, it's actually the content of the activity. And so why this would, like, how this would really shine is if you've got a relay 1 and relay 2. And a client, and they're both sending a stream of objects. And we'll repurpose C to be consumer, so P is producer. Well, we'll take, say they produce to one spot, and then relay 1 goes to relay 2. So we push out the event. The event has the ID, which is the content addressable hash, and then that goes out here into here. So I mean, why this might not be like the best use case for it, but we can then deduplicate the events that come in. We don't have a sequential number. It's basically like a really good natural key for things. The way that I'm using it is for, like, it's really good for, so you take the hash of, say, a note, and then you can publish just the hashes, and so you could include an attested timestamp within the hashed data, and then say publish to Twitter the hash of your content. You know, that could even be another attested timestamp, but you don't actually reveal the content. You can only get that hash back if you have the content. Now, say someone has a printout of your content. They can take the printout, put it back into a data structure, take the SHA-256, and authenticate that the printout is valid. So it's a different use case than what they use it for, but it's just to show the versatility of using this content addressable hashing method. So that's one. Number two, this is what Tor does, and I had this on the City Apper website for a while, is public key as identity. So what this does is a public key is a function of a private key. But a private key can't be gotten from a public key. So this is asymmetric cryptography. So basically, there's a good video on YouTube that talks about using color mixing to explain asymmetric key exchanges. And so you have a shared color, and so your public key is your shared color. And so your identity on Tor is the onion : / public key . And then that's your host name, and so you just run a server on that. And so you don't need a domain name, you just have your public key.onion. And you could do like a domain alias or whatever for browsers that support Onion, which most do not. On Windows S mode, there are none. On iOS, I'm not sure, I haven't looked. Brave browser is one I believe does. So this says you don't have to register a domain name anywhere. And only the person with the private key can start up a server on this host name. And so another thing that this does is use your public key as your identity. So that's two things that are really cool that it does. So use the content addressable hash, use a public key as the identity, and then number 3, I think, was just using timestamp at attested timestamps. Now that is added later, NIP 03. And unfortunately, that is not actually part of the hash. It's added onto the NIP event, onto the whatever Nostr event, which does not get included in the hash. Sorry, the signature. No, the ID. Yeah, so it does use the timestamp, but it does not use the attested timestamp. So I don't know if that's been solved or not, but that's just one thing that stuck out to me as possibly an issue. So another thing. So I have 2 suggestions as well. One kind of works with it as is, but the other is just like a big question mark as to why they went with WebSockets instead of SSE. So personally, I would definitely start with SSE, server sent events, because it's a much easier spec to implement. Especially like having been through a WebSockets deployment with iOS and web clients, and just like switching from Node to Java server, like we had like a guy on it basically. It was like his job to do WebSockets, and I don't know if it's gotten better since then. That was like 2017 or 16, but yeah. So SSE is just a much easier standard. The only downside I can see is there's a limit of 6 connections per browser. So could be an issue. Really, I think browsers should fix that and do it a different way. Up the limit, because SSE is a good spec and it should be used more. But it's a lot more like long polling than WebSockets. It is single directional, but you can, just use a regular post request to get data in, and then the response, change state, whatever, can be sent through the SSE that's kept open. And the next one is tag for the last published event. So basically, what's to stop R2? So one is you have redundancy. But say R1 and R2 have like a blacklist that they're using to filter out events. So say that they both X out this event. And so you get maybe 2 copies of the first event, no copies of the second event, and 1 copy of the third event. How do we know that there were 3 events? Right? So my thinking is just like a Merkle tree. That's what GitHub does. That's how Git works. Each commit has the ID of the previous commit, and that commit has the ID of the previous commit, right? So with these right now, there is a way to tag your events to reference another event, but it doesn't say what exactly that is. Like, is it a retweet or a quote tweet or a reply to? So there might be some specific standard that sets it as reply to, but it's actually something a little bit different. It's more like an integrity. It's like it'd be almost tag M for Merkle. do tag.m for Merkle, where this event has the ID of the previous event. So that's how we know it's missing, because this event is pointing to an event that we don't have, right? And so the chain is broken somewhere. So we have to maybe find an R3 that this guy is also publishing to. And then that would have given us the next one. Now we have it. And now this one has the Merkle of the previous one. And now we have, say, received 3 copies of that. So, yeah. This maybe should have been 2 different videos, but this is my day's work. So, cheap MF. No. You know, I am literally, like, stuck in the Midwest. It's, like, super snowy outside. And if I run out of food, I'm done. And, you know, it costs a lot of... It costs, like... You know, I've got to... I don't want to give my whole situation, but it's going to cost a good amount of money to get back home. I came here because of pandemic, and, you know, you know, watch my previous videos if you want more details about that. But, yeah, what was I going to say to justify it? Like, what am I doing to provide value to people? I don't know, man. I don't know. So, I guess if I just have to live day by day without having enough income to do anything with. I could starve to death at any time, and that would not be fun. So, yeah. So public keys is ID, content addressable hashing, attested timestamps, and there's a bunch more stuff in this Nostr protocol to go through. Deleted events are... So there's a new event to say that an event was deleted, and that... You know, so basically, this still works in the deleted case as well, because we get a deleted event that has the content of that. Yeah. So, you know, I was stuck in the onion mindset, but I could have used the public key as identity without onions. You know, it's definitely in my mind, but I'm one person, I can do so much. And, let's see. I'll close it out here because I'm hungry. I do intermittent fasting so that it won't hurt so bad when I starve. Kidding, but yeah, I mean, I made this app, and oh yeah, so additionally, so this app has pluggable backends, so I started making a backend for it just based on reading the specs without looking at any other code so far. So it's just pseudocode based on what I've read in the specs. And yeah, maybe... But there's no shortage of clients for this. So it's like, again, I'm not doing anything groundbreaking here. Basically just, you know, an exercise for myself using Python, building it into this existing code. This is the app. If you're on Patreon, you get early access, including, what's this? YouTube? What's YouTube? Huh? Okay, I just got to renew the token. But yeah, so you can add your YouTube login. I did add a link to, if you want to get your own managed server. I set up this business in February, and I basically just need interest to turn it back on. So you can email that address there with subject Mastodon server, the one in the bottom left of this window. And yeah, then maybe I don't have to beg for Patreon so much. I really want to do everything open source. Like, you know, I swear I'm not just grifting. It's just like, you know, I need to support myself somehow. Food costs money. If I could, I would just have land and grow everything And yeah, I mean, I share my recipes on Twitter sometimes too, all vegan recipes. So I know a lot of people want to bash on the vegans, but anyway, your money will be well spent if you help me out. So thanks for joining, and I'll see you soon. Have a good rest of your day. Good night.